We can talk about division of rational expressions here. Here I have x over x minus 3, and I have 2 over 3x plus 2, and I'm dividing the two together using the kind of traditional division operator here. Or maybe even a better way of writing it in a calculus class would be to take this expression and then divide the entire thing by 2 over 3x plus 2. And notice how I'm making that division bar fairly large just to emphasize the order of operations. We do this first, we do that, and then we divide the results. In order to carry out this operation, just multiply by the reciprocal of the denominator. So it'll be x over x minus 3, and then we'll multiply by 3x plus 2 over 2. To multiply rational expressions, we just multiply across. So I'll have 3x squared plus 2x, and then I'll have 2x minus 6, and we're done. Sometimes we want to simplify what we would call complex or compound rational expressions, and those are ones that have multiple divisions in them. So I might see some terms being added, some rational expressions being added. I have another rational expression here that's being divided into this sum, and we'd like to simplify these expressions frequently. You have some options in the way that you might do this. One choice is to just follow the order of operations, which is to add the two terms in the numerator together and combine that into one fraction, and then it will look very much like the previous problem where we'll be doing just division of rational expressions. So to do that, I'm going to find a common denominator. This one needs a factor of y, so I'm going to multiply by y over y, and this one needs a factor of x. And I'm still dividing everything by 1 over x times y. So now there will be a common denominator of x times y in the numerator. And there'll be 1 times y plus 1 times x, or just y plus x when I add those two fractions together. And I am still dividing everything by 1 over x times y. So now I'm dividing this and this, so I'm going to take the numerator and multiply by the reciprocal of the denominator down here, xy times over 1. Observe now I have a factor of x and y, I have a factor of x and y, they're going to cancel out. I'll have y plus x, and those will cancel out completely when I multiply, and I'll just be left with y plus x. Notice I can put any real numbers in here for y and x I like. This expression makes sense, but this equality only makes sense provided this one is defined, and I cannot plug in x equal to 0 or y equal to 0 in any of these expressions here. So this equality is valid for y not equal to 0 and x not equal to 0. As I mentioned, you do have options in the way that you simplify these complex rational expressions. Here's the same problem again. One thing you could do is multiply the top and bottom by the factors that appear in the denominator to effectively clear the fractions from the numerator and denominator completely. In this case, this has a factor of x, this has a factor of y, this has a factor of both. I'm going to multiply the top of this by x times y, and I'm going to multiply the bottom of it by x times y. When I distribute that through on the top, so I'll multiply it through each term, I'll get xy over x plus xy over y. So distributing it through. In the denominator, I'll have xy over xy. By design, every factor in a denominator of these smaller terms will cancel out completely. So I'll have x's canceling here, giving me just y. I'll have y's canceling here, just giving me x, and then these will both cancel to give me 1. And so we see again the same expression that we got before, y plus x. Simplifying these kind of compound or complex rational expressions is an important skill. So let's do one more. You could, if you like, first find a common denominator and simplify the numerator here that I'm circling. Instead, I'm going to multiply the top and bottom by the necessary factors to make all the fractions in the numerator cancel out. So I'm just surveying the expression here. This has a factor of x plus 1. This has a factor of x plus 2. I'm going to multiply the top and bottom by those two factors. I'm not worried about the x minus 1. There's no extra ratio in here. There's no rational expression in the denominator to want to clear denominators off. So now we're going to take this stuff and we're going to distribute it to each term. And when I do that, a factor will cancel, but one will survive. So when I multiply this times this, the x plus 1 is going to cancel, but the x plus 2 will stay, and I'll have 2 times x plus 2. Same thing here. When I multiply this times my common factors, the x plus 2 is going to cancel. The x plus 1 will survive. So it'll be minus 3 times x plus 1. In the denominator, I just have that factor times these two. One of the keys to doing this carefully is just writing carefully. Notice how I've kind of keep the division line aligned here to help me kind of keep track of what I'm applying these things to. I'm going to simplify the numerator now just by distribution of terms. 2x plus 4 minus 3x minus 3. Denominator, still the same product of three factors. Then we just combine like terms. I see 4 minus 3 gets me 1, and I see 2x minus 3x gets me minus x, and I have the same denominator as before. Notice this factor up top, 1 minus x, is just the opposite of x minus 1. And I wrote it that way because I see a factor of x minus 1 in the denominator. Minus x plus 1, same thing. Now we can cancel that factor of x minus 1, and I'll be left with minus 1 in the top and x plus 1 times x plus 2. Notice how I resisted multiplying out in the denominator because I was unsure about what would happen once I simplify the numerator. Would there be some canceling or not? So leaving that factor is generally a good idea unless you have a motivation to multiply it out. Now I will. X squared plus 3x plus 2, and there's our final answer. Notice that this expression here is defined provided x is not negative 1, nor is it negative 2. Same restrictions apply to this expression with the additional restriction that x is not 1. So this is equal to this for x not equal to 1, minus 1, and minus 2.